Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will do a homework problem from section 11.2. We have a table below that lists the number of games played in the yearly best of 7 baseball championship series, along with the expected proportions for the number of games played with teams of equal abilities. They want us to use a 0.05 significance level to test that claim that actual number of games fit the distribution indicated in the expected proportion. So they're saying that this best out of 7, so one team can sweep, win all 4 games and be done with a series, or they can win 3 games and then lose another game and then win the 4th game, and then they would have played 5 games there. And so the actual numbers here are 18, 22, 21, and 38. So there's 38 times where they played all 7 games. Now these are the expected proportions. It's all out of 16, and they're all proportions, so they're all numbers between 0 and 1, and they're written as fractions here. So the alternative and null hypothesis. The null hypothesis should be that the observed frequencies would agree with all of the expected proportions. So let's choose this one. Observed frequencies agree with the expected proportions, and for that to be wrong, or the complete opposite of that, would be at least one of the observed frequencies do not agree with the expected proportions. Okay. So those are our hypotheses, and this is going to be a case where our goodness of fit test does not have equally likely outcomes, and the outcomes are given here according to the expected proportion. So we will work on finding the test statistic and the p-value by going to StCr. So let's open this up in StCr. So this is our StCr. We have the number of games played, so these are just categories. They're going to mean nothing to any of the calculations. These are the actual contests. They're observed frequencies, we would call it, and these are the proportions, but the expected frequency would be the proportion times whatever the total is. And if you're doing this work on a calculator or somewhere else, you're going to need to figure that out. But since we're doing it in the StCr, it will actually do the figuring out for us. So we'll go to Stat, Goodness of Fit, and this is going to be a chi-square test. We're going to select the observed columns. That's the actual contest. Now the expected is not going to be all the same proportion, so we're going to have to select the expected proportions. And then let's display the expected values so that we can see it. Okay, let's do the computation, and here we go. So given those proportions, the expected proportions, looks like they're counting 99 times that this series has happened, and out of those 99 times, according to the expected proportion, out of those 99 times we expect about 12 of those series to go 4 games, so that's a total sweep, and we would expect about 30 or 31 of those to go either up to game 6 or game 7. Okay. For the sake of this problem, we're just really concerned about figuring out the test statistic and the p-value. So the test statistic is 7.667. So let's get that down here. 7.667 for our test statistic. And our p-value was already given in 4 decimal places, 0.0534. And then now 0.0534 looks like it's going to be slightly slightly bigger than the significance level that they gave. So because it is bigger than that, we will fail to reject the null hypothesis. So we fail to reject the null hypothesis. Now the claim is that the actual numbers fit the distribution. So the claim is actually the null hypothesis, which we are unable to reject. So we fail to reject. There's insufficient evidence to reject the claim. And so we were trying to reject the claim that the actual numbers fit the game. Okay? Now, since we were not able to reject that, we can probably conclude that it doesn't fit this proportion, so it might fit another set of proportions that we can come up with. Okay, I hope that helps.